Hello students, welcome back. Let's go back to parametric curves just one more time, because there is one topic that I did not cover. That is the justification behind this slope formula. Why is the slope y prime over x prime evaluated as t0? Other than that, we covered everything. We went through the step-by-step process and we went through a couple of example problems here. There are more example problems, but I'm going to leave those to you. And the only thing that we did not cover is why do we have this m equals to y prime of t0 over x prime of t0. The others are pretty much straightforward. When t is given as t naught, x naught, y naught, just plugging in and you're gonna get those. But this one is not that straightforward. Why y prime over x prime? Why not x prime over y prime? Well, as a matter of fact, here it is. Here is a part of the graph of a function y equals f of x. And how did it get the tangent line? We began with the slope of secant line, this green, and then rise over 1 was delta y over delta x, the difference of y coordinate over the difference of x coordinate, and then getting delta x going down to pretty close to 0, we got the derivative. And then what did it get? We ended up with this delta x, where's my delta here? Yeah, delta y over delta x converted into dy over dx in infinitesimal. Both delta x and delta y are getting so close to 0, we get infinitesimal over infinitesimal. You can regard it kind of like 0 over 0 type limit. That's what we have over here. Now, if you go over the parametric curve, something similar is taking place here. We are looking for a tangent line and the difference of y coordinate, difference of y coordinate over the difference of x coordinate. And the difference of x coordinate is getting closer and closer and closer to 0. We have the same thing here, but there's just a little bit of wrinkle. X is not the independent variable, t is. So we have this kind of oh, actually I skipped a step. Okay, let's get that computation back. So we have the slope, delta y over delta x, and that is getting closer and closer and closer to dy over dx. Yes, that is true. But then again, we can view it in alternative fashion like this. From here, divide both the numerator and denominator by delta t, the difference of t coordinate, the difference of time. Then what happens to the numerator? The numerator is delta y over delta t, and that's getting closer and closer to, well, here it is, dy over dt. And the denominator is dx over dt. And those are the derivatives, y prime over x prime. Here, y prime over x prime. Of course, the point we are interested in is t0, so we have to evaluate it at t0. And that's why we are getting y prime over x prime, not the other way around or anything else. From slope of secant line, a little bit of algebra, and then eventually taking that limit, we get the derivative over derivative, which is y prime over x prime. And then we just evaluate it with respect to t equals to t0. Voila, what do we get? We get the slope formula. That's where this is coming from. Otherwise, we covered everything. Well, of course, one more thing. Let's go back to this curve. Yeah, I like this curve. And this kind of point, the slope will not be well defined because we're going to get a vertical line. And another point like that around here, in that case, we're going to get a vertical line, x equals x0. I wrote one such problem in implicit curve. In parametric curve, I don't know whether I wrote it or not, but I could well write it. So please consider that. For graph or function, we don't have to worry about the vertical line, but for implicit or parametric, yes, we have to.